In this video, we talk about database applications with SQLite, which is a package of Python. So the first thing to work with a database is to create a connection using SQLite 3 package. You call the function connect and give it the name of the database file. The result is returned as a connection, and later on the connection can be used for a number of activities, such as to create a table, to insert data into the table, to select data from the table, etc. This usually put in a try except structure. If there is something wrong with the connection, the error can be printed out. Usually when we start with a database, we have files, and basically there are many CSV files that we need to import into the database. So usually we can do this via pandas. We read CSV files into a panda data frame, and then later on use the toSQL method to import data from the CSV file into the table, and we give the table name here using the condition. And here we say if the table exists, then we would append data to the table. To create a table, or in general to run any SQL statement, the way that we write code is very much similar. We use a try except structure. Given the condition, we create a cursor and use a cursor to execute any SQL statement. So for creating a table, we use create table SQL statement. Create table if not exist. So if it exists, then it doesn't create the table, and if the table doesn't exist, then create a table. So create table, right? If let's say you give it a name, so table variable stores the name of the table. So then you can get that variable with the rest of the string that forms the SQL statement. So looking at here, you can see the statement is create table if not exist, and then table name, and then in the parentheses we have a list of fields such as ID, such as username, such as password, first, last, begin date, and end date. And the second next to the field name is the data type, right? Integer, right? Text, 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 and text. The ID field is primary key, right? Primary key here, it means that you cannot have more than one ID, on the same ID in a table. And not null, right? If you try to insert null into the table, then it will raise an error. And if we have now, meaning you can insert now into the table without issues. Inserting data into table, you use insert into. In this example, we insert one row of data into the table, namely users. After the table name, we have a list of fields such as ID, username, password, first and last, and then after the keyword values, we give it the values for the corresponding fields. For example, for ID we insert 1, for username we insert admin, for password we insert something that is previously stored in the variable password. For first we insert admin, and for last we also insert admin. Now, data exploring. There are several ways. You can either just run a select statement, such as select star. Right? Select star meaning select all the fields. Select star from the table, and in this case, the table namely uses. And then use the execute function, or the execute method of the condition. Execute that SQL statement to get the cursor, and from the cursor call fetch all if we want to get all the records, or fetch 1 if we want to get only one record. And the data is then stored in uses. And then loop over uses, let's say for 5 times, to print each row. Then what we have is here. So basically what we see, each row is a tuple. The printout is nicer if we use the data frame read SQL query function. So give it the SQL statement and also the condition. The result is a data frame, and then you can just call head on data frame. To select data, use the select statement and put the list of fields that you want to select from after the select keyword. So here we select user ID and device from the table uses using this condition, and to get some result that we print using the head function. You can group by to split data into groups based on some criteria. And in this example, select user ID and count star and give it an alias, namely num, from device group by device. So for each device, it print the user ID. It print the user ID and the number of devices of that user ID. So this is what we have with group by. Filtering is done using the where clause, right? So this SQL statement select user ID and device from this table device where device like iPhone. So like operator matches the string that you give here. So anything that contain iPhone, right, would be returned. And this is what you have. There are other Boolean operators such as greater than or equal, right? Less than or equal or not equal, and not equal. You can sort data using order by. So order by can be used in combination with others such as group by. And the result will be sorted by default. It is ascending. You can also put the keyword descending to make it sorted in the descending order. There are common aggregation functions such as min, max, count, sum, and we saw some examples that we use count. This example uses max function. So select user ID and max of platform version. And because this is a function, so you should give it an alias, which is in this case max version from this table, namely device, and group by device. So for each device print the user ID and platform version that has a max value, and also order by max version by the descending order. This is what we have, which is 5 top records. How do we update data? For updating data, use update table statements. So update this table, and what do you do? Right? Set first, change the first name. Set the first name to admin, where first is admin. Right? This is lowercase. Change it to uppercase. And then just execute using the condition. Now let's talk about join statement. SQLite supports inner join and left join. The syntax for inner join is like this. Select select, and you have a list of fields. In this case, I select all the fields from device, right, from device table, and inner join with the other table uses on, right. This is the fields that you have, or the tables have in common, um, to link from one to the other table, and which is use ID, right? Join on this use ID field using this condition, and this is what we have. So previously we saw how we did this using pandas data frames, and if data is stored in a database, you can also use SQL JOIN statement. Left join is used to show all devices, in this case, even ones that do not have users. So instead of writing inner join, we just change it to left join. And this is what we have. You can see there are records with NAN in uses, right? So there's records on a device table, but don't have matches in the uses table.